Hello, everyone. I'm very happy to be here. What an exciting event. And I'm joining you all from Toronto. And first of all, I would like to thank the organizers for just a great lineup of content and such a great first Airflow Summit. So let's talk a little bit about building reusable and trustworthy pipelines. This is the high level outline. So I'll talk a little bit about the context, the motivation, set the stage up, discuss design requirements of how we can build a system and what the requirements will be, and then a proposed solution, and then end with some example code. Um, so before that, hello everyone again. I'm Nehil. I'm a data engineer at Snap Travel, and we have a team of 8. I think Fofo gave a good introduction of what Snap Travel is, but in elevator pitch, it's a messaging commerce startup, very similar in terms of data to e-commerce startup. We help people buy hotels on messaging, and I have done all slew of things in the data space, from data infrastructure engineering to analytics engineering. And the stack I'm right now loving is Stitch, Airflow, Snowflake, and dbt. We can chat about this on Slack later on if you guys are more interested in some of the components here. The purpose of my talk was to really discuss the tool set that we have today as it pertains to BI pipelines, which is just one type of pipeline in kind of a slew of different types of pipelines you would see being built and run on Airflow. But what does it pertain to is the data analytics space, where you're trying to use data to generate some business insights. I wanted to inspire the community with some lessons I have learned along the way while scaling and working with so much data in a very fast-paced growing startup, and very eager to hear feedback from everyone on what they think this approach would look like for them, and what are some nuances that they see as well. So it's a very generic question that I see most companies almost always ask is, how are my company's metrics? So let's say, gross revenue, some financial metrics like contribution margin, your active monthly users, DAU, MAU type of stuff, retention rate. These are metrics that are not super trivial to calculate, given the amount of mishmash of data sources now companies use to um, get to them. It's not a trivial job anymore. And I found that Airflow is one of the places where most of these pipelines run to generate these metrics to derive business value and insights eventually. And one important thing to note is, in today's world, the business changes so quickly that the definition of these changes quickly. So for at Snap Travel, I've found that like every 2 quarters or 3 quarters, when we release a new feature and we change the definition of what buying a hotel means, the definition of revenue keeps changing, which means you have to adapt your analytics to the definitions that are changing for the business. Otherwise, there's this lag between when business is making decisions versus what we are reporting on. To make it specific to our use case, I wanted to motivate with an even more fun use case where, how is my Airflow repo doing? So assuming I'm someone like Bolke or Max, who's actually one of the PMC members of Apache Airflow, and I wanted to look at being data driven to take some actions in how I want to run my repo. And so I came with the idea, okay, let's look at some metrics like numbers of PR merged, number of PRs closed without merged, number of PRs open, etc. And how would I go about building that? And how can I make that basically reusable and trustworthy in the pipeline when I build it? So first of all, like the most common way to think about and traditional way to think about it is, I would write some script to fetch data from GitHub API. We can call that the extract phase, and then we load that data, or we transform that data to process the metrics. And then finally load the report into a database or what have you, any kind of data store, which then is connected to a BI tool, something like Superset, Redash, Metabase. There are many to report and use the business metrics and get the answers I want. But at this point, I would also take us through a thought experiment. Let us consider a few scenarios of what happens when the first time you deploy the pipeline to production, it failed. The most common reason I have found in my experience is it fails because the data broke in a way that you were not able to replicate in your development or your even staging, like UAT environment where you QA'd it. And that is because the data types that the API was returning were not true. So sometimes you thought it is an integer, but they were returning strings as bad data, or the index column that you chose had null values and stuff like that. And so the pipeline couldn't function when it was pushed to production. Another one would be as so this is similar to business changing. Now I have mastered the PR workflow for Apache Airflow. I have a good documentation. Things are going well. There isn't too much churn in PRs, etc. And I want to focus more on issues and comments and engagement around the repo. And now what happens is I have to go back to the drawing board of, okay, let me plumb more of the fetch to get issues and comments from the GitHub API, transform that, load that. So it's almost like building it all over again, but just with more type of data. And I found this pretty kind of toil heavy. You have to do the same process over and over again for different types of data sources or different types of needs of the business. Another one is GitHub released a new API, and they wanted to shift around some data from issues to PRs or PRs to issues, what have you, because the way they fundamentally look at things have changed. Um, Again, you go back, you modify your fetch script to work with the API, but not only that, now in the transform step, you have to see where all the changes have to happen for the change data set. And again, that adds a lot of like manual work for data engineers to do or the analysts to do. Now let's pose the question, okay, I figured these out, but now I want to do it for all the other projects because this is working out so well. And I will have to kind of refactor the pipeline in such a way that I can do it for I can parameterize it in such a way that I can do it for other projects. Um, and lastly, GitHub adds more and more functionality. So now they have an insights tab, which is showing some of the same things, but the numbers don't match. And after doing all this work, you lose trust of like the executive members are actually trying to make business decisions because they're like, GitHub, who's the source of this information, is trying to give me something else as compared to what you are telling me in terms of the metrics. And that has been very detrimental, in my opinion, with and my experience for a lot of morale of the team and stuff like that. So I'm aiming to kind of solve these problems. And if it was not a virtual conference, at this point, I would kind of ask people and throw people on how many people have felt that and stuff like that. But I'll assume that this is a problem that a lot of us face. So let's classify the problem. So these are the different ways I would kind of classify problems. One is toil. Toil is the amount of manual work that was being done to keep the pipeline up and running, to adapt to changes. As the requirements change, you keep changing the code a lot, stuff like that. Because of that, you cannot scale your data analytics. So what happens is, as the business grows, you have to add more engineers for the amount of analysts who are doing the transformations or who are consuming the data. Um, then data discovery. So even if everything is ready, not it is not always the case where the users know what data to query themselves to find the numbers or the metric or whatever they want themselves. Data trust, this was the one where the numbers don't align, or there is some leak in what we assume is the metric going to look like, whereas what the data is showing the metric is going to look like. And that leads to a lot of mistrust. Or if there is problems in uptime, so if the data doesn't even exist when we say it is a reliable pipeline, that leads to a lot of data trust. Some efficiency things, so throw over the boundary happens a lot, where data engineers build some pipeline, they throw it over the boundary to the analytics team, which might be sitting with the business domain itself. They do something and then they're like, okay, this is not working well, we need XYZ more, and then they throw it back to the data engineers. And this whole loop creates a long cycle of delivery to business value in a way. And because there are multiple people nowadays in a given pipeline from source all the way to business decisions, it is sometimes hard to pinpoint who is owning what part of it and what happens when something goes down and who should be taking care of that. So at this point, I was wondering and discussing with the team, like, how could we solve this? Reading Max's blog post about, rise of data engineer, also the downfall of data engineer. Really great pieces. I recommend you guys read it. And an inspiration there was, build tools and infrastructure and framework and not pipelines. And I thoroughly agree with that in today's world, where data engineers should not be manually just adding more and more data pipelines, but building uh, kind of like um, meta data engineering. So they should build infrastructure or frameworks to build pipelines scalably, and that's what I wanted to talk today about. So let's look at some design requirements of what the system would look like or the framework would look like, and then we kind of put things to components to solve that. So the first one is it should be super fast delivery. Today we are in a place where business is making changes very quickly, is trying to learn from data and make decisions as soon as possible. Amazon promises same day delivery, so inspired by that, we should be able to get people who come up with a hypothesis about business, have answers for that as soon as possible, because sometimes it's too late to even act on it, and then what's the point? And one way to do that is have reusable components, so you don't do repeated work, and you just optimize for the parts that are just changing to deliver value. Another one is single source of truth. So these three things, standardization, data lineage, and empower the non-technical folks, is what you get when you have all of this, again, going from data source to business value in one place, and you don't have multiple components someone has to touch to understand what happened with my data, what is the status and history of where the data is or where the reports are and stuff like that. This helps people move towards self serve, because they only have one thing to learn. This is all there is for their specific report or their specific data being processed. And I think this, as I said, empower non-technical folks who are actually the consumers of these type of pipelines. And yeah, and it also, sorry, helps on understanding the data lineage of how the data is being processed before they make data like reports and analysis, so that they can solve the curiosity of, yes, this is the right place that we thought our revenue numbers are coming from, because there can be multiple sources in today's world. So this framework would be something we would build for data engineers to set up and to kind of operationalize, and it should be easy to consume for them. And hence, open source is something that comes to mind. Similar philosophy as Airflow, you should have something like pip install Airflow, and you have a local setup running right away. Quick aha moments, right? So this should kind of follow the same steps and same ideology. This also lowers barrier to entry for a lot of data analytics, which hasn't happened just yet. I feel like there are a lot of tools like Stitch and Fivetran which are doing data integration well, but they're basically pay to play. And because it's so hard to set things up locally and self-host these solutions without too much operational creep, um, most of the people end up using Stitch or Fivetran, but that's not always ideal. It comes with an upfront cost. So another one is promote data integrity. So this is super important as well. As I talked about, data trust. I have found many times that the hard work done by the whole team is kind of thrown off just because the people making the decisions don't trust the data, and that is because a lot of the result of these pipelines is undocumented and untested, which is bizarre if you come from a software engineering world, sorry, where you have different types of tests. You have unit tests, you have integration tests, you have functional tests, and you have end-to-end kind of tests. I understand that it's been hard to do those testing for data pipelines where code and data both are moving, but that is an important feature to have if we want to move towards a self-serve, trustable pipeline. Um, I touched upon this a little bit. This framework should be something which takes in input, like a template or a spec, and generates the pipeline automatically. And at that point, it would be the metadata engineering. I think Max gave a talk about advanced data engineering patterns, which slightly talked about this stuff as well, where you're trying to generate different metrics given a YAML file. And this framework would be similar to that in some ways. Lastly, the framework should be able to adapt to the frequency of changes happening in the data analytics lifecycle. So the data at the source rarely changes as compared to the changes happening on the business side, which is real time or even daily when they're asking questions of data, or they're changing the definition of how they want to look at data and stuff like that. And so this framework should kind of fit well and reduce the amount of churn happening in places where there isn't. So let's look at what this solution would look like given these set of requirements. Um, so conceptually, we will have something like this. So there is a library called Great Expectations, which we'll get into in just a bit. But you test your data at the source. Does GitHub API have all the data that we need in the format that it's promising it'll give it to me? That is just the example here, but you can see as the type and variety of data sources change, this becomes really valuable. So once GitHub, I can check that GitHub is giving me all the right data I need for my metrics calculation for Apache Airflow repo. I can then extract that data and load it right away. We will use something called Singer there. Once the data is loaded into my warehouse or data store, I would then check if it was correctly loaded based on my assumptions of what the extract and load should do. And once that is there, then I will transform it and then check again on what are my business assumptions of that data and are they matching with what transformed. Basically, checking the logic of the transformation. At that point, if it is a success, after doing all this, I would just say that I have a production ready data set that can be used for reporting and making business decisions. So that's the conceptual flow we would want to establish. One thing to note right off the bat, traditionally in the initial example I showed, a lot of things were being redone because it was ETL where we were extracting, transforming, and loading, whereas it would work well for this specific type of pipeline. Again, I would say that multiple times just to say that this is the constraint that we're working on data analytics pipeline. So yeah, with this specific constraint of data analytics pipeline, ELT would work much better. You load once and you transform multiple times, and you kind of empower people who are making the decisions to do the work so that they can move fast. It reduces complexity because there aren't that many moving parts. You almost always extract all the data and load it. Also, because it is only possible recently since cloud-based data warehouses and data stores have become that powerful and easy to use that you can achieve this. You can load all the data and then keep transforming it as many times as you want for the business use case. Another thing is that the speed to delivery changes. You can deliver things quickly because now when I want to look at my issues and comments, I almost already have all the data. I just need to add some SQL to transform that data to get the metrics I want, number of issues created per day or whatever you have. So ELT really solves the problem in some ways. Now let's look at each step of the ELT pipeline that I outlined early on. So validate your source data, which is the GitHub API in our case. So I would like to propose this package, which has been gaining a lot of traction in this space. Great Expectations is the Python library, which helps you write declarative assertions on your data. So you can say things like, expect my column to exist and expect some property of my table, compare different columns, compare different tables, stuff like that. There are a lot of expectations which encompass all the best practices you would want to test already coming out of the library natively. You can extend that because it's a Python library with your own assertions as well. They have concept of data sources. So these are some of the data sources. You can add more. And there are a bunch more as well, where you examine a batch of data for these expectations. And if something breaks, then you get alerted. Why I specifically like Great Expectations for this are three reasons. One is profiling. So they have built this concept of a profiler for a data set. What it does is it creates a scaffolded kind of set of test suite for you out of the box without doing anything. And that really reduces your barrier to entry to test data. And of course, it's extensible and you can customize it for your own use case, but it has a few profilers inbuilt. So you can run your CLI command with Great Expectations and it will create a set of test suite for you. You can just simply change some config and it is yours for using. Another thing they have is they have written kind of a way to parse these tests into data docs. So you write these tests which are explaining assumptions of your data, and then they produce that as data docs. Again, a great way to understand what we assume off of our data right off the bat. And a specific feature for what we want is, when the GitHub thing breaks, I don't want a data engineer or someone on the team actually to go and pull out the logs and then send it to GitHub API and say, it's not working, but rather it can just automatically send the docs and how the test failed back to GitHub support email, let's say, for our use case, as notifications. So that's solid as well. So that kind of takes care of our validation. And the next step will be, let's extract the data, assuming GitHub is giving us all the data that we want. And for that, let's use Singer. So Singer is an open source spec that Stitch created for extraction and loading of data. It's made of two things. One is tab and targets. Tabs are scripts that extract data and output it to standard stream. And targets basically consume it and put it somewhere. Somewhere is defined by the code. Again, you can decide what it can be. And they use JSON to communicate with each other. So simply assuming I'm building it for the first time, I can just write tap GitHub. So of course I'll have to install the tap GitHub and target Postgres, but that's simply as pip install, right? But once I have those in my environment, I can just do tap GitHub config, pipe that to target Postgres config. I get my data going from API into Postgres in like less than 10 minutes. You have everything ready. And then the state JSON in the end is an output that comes out of target, which kind of snapshots that this much work is already done. So suppose you kill the process and you run it again, it will work from the previous state of the DAG or the previous state of the process, where it will pick it up and not redo the work of extracting all the way from the beginning. So why Singer? Why Singer is because it standardizes communication using JSON, and JSON is great for rich data types. It is super easy for humans to debug, and it is language agnostic. So actually, your taps and targets can be any language, as long as they're installable as a Python package. You can basically write them in any language. Um, and then it is incremental out of the box because of the state file or the properties the state file has. Great thing, side effect you have of extract and load, which Singer kind of gives you as well, is documentation. You don't need to have documentation of your extract and load, because documentation of the GitHub API is a documentation of your raw data, because it's a one-to-one copy of what happened, and you don't have to document it. The best part, again, is you see your data in under 10 minutes in your warehouse, and you can at least start playing with it already, which I found is a big win over what used to be the case before, where someone would actually have to write some code to test it and then deploy it and see what's happening in their database, and then kind of iterate on it. So this is the list of tabs. It's very long, so that's the point. I don't want you guys to squint, but the idea is these are the tabs that already exist out there, which means you can already ingest data from all these sources automatically in under 10 minutes already. And in the end, I'll put a call to action. I'll repeat it, is if the community keeps coming together on this, we will be able to grow the amount of taps to all the different data sources that almost ever exist. And this work has to be done once by someone, and everyone else can just reuse it and move off of that. Similar to the concept of operators. In Airflow, once we build an operator, most of the people can now work with that data source and do the work that the operator is doing without writing that code themselves. So once we have the extract and load done, then it's time for transforming it. And this is where I would say most of the complexity and most of the brittleness both happen. And that's why I moved it to the end, and extract and load just became simpler. So here I would propose we use a package called dbt. It is again a newer kind of tool in the space, where it helps you transform data effectively in your data warehouse or data store, and it reads and writes both from the data warehouse, as you can see in the diagram. It expects raw data to be there. It does all the things with data in transform world, and then put the transform data as an output in the data warehouse as well. And then you can use that downstream for whatever use cases you have. Everything, as I said, is transformed in SQL. So SQL is the lingua franca for DBT and also for people in the space. I found that it's almost a must have, or if not, people can easily learn it. So SQL is a great choice for this. Again, this is possible. A tool like this is possible because we have these cloud-based data stores, which make it really easy to spin up a lot of compute and cheap storage quickly. So that's something that has been great. To give you more context, so DBT does this thing where it creates a graph of dependencies similar to Airflow tasks and DAG for different models which are working on the data. So in this diagram, you can see from left to right is left is where the source is and right is where the result is. And as you write your SQL, as the GIF is showing, once you write a from ref and left join whatever ref, it will connect the dots together. And now you know that once you have to make a change to this model, these are all the other models that will be affected by this. And this is the whole chain of operation that has to happen. And that has been very useful for the analyst to kind of tame the beast of transforming all the data in the warehouse. Another great thing DBT does, it is creates this static website of all the data that is in the source and that it touches basically. And it shows you the documentation as it's documented in code and all the tests that are run on it. Not the outputs of the test, but the assumptions. So it will show you, this ID is being tested for unique and null and stuff like that. I'll show you a snapshot of what that looks like just in a second. It also shows you the lineage again of where this data is coming from in a very easy fashion. You can just search for your data set with fuzzy search string matches at the top, and then you will be presented by a list of things, and you can choose which one you want in self-serve. Again, super good feature that has helped us a lot. So some of the features I specifically like for our use case is it makes code modular. So I would like to go back to that concept of ever-changing business definitions. So suppose revenue is changing again and again. And what happens is if the definition of revenue changes, just like software practices, if you define it once and keep it dry, then we only have to change it in that place for it to be used everywhere downstream. And DBT achieves that by using like supercharged SQL because they sprinkle Jinja in between. So you can have reusable components. So you can define your revenue formula once and then use it everywhere downstream. And with dependency, you will know what are all the models that actually depend on the revenue formula as well. Testing is first class and it makes it very easy to test the models. So you can see it's YAML, which is very static and easy for analysts to work with, where it's saying that the columns order ID should be unique and null because it's probably the primary key of the orders table. Status should have these accepted values. And you're kind of encoding your assumptions of what the data is through these tests. And if they break, then you know that you catch the things early before bad decisions are made on it, and then the whole organization is hurt because of that. Documentation is also first class. So in the YAML, again, you can just add descriptions to the table or columns, and that populates the website I showed you before, which is generated statically, and you can generate using CI or whatever you have. It has been getting a lot of great adoption. This was recently published on their blog, and a lot of activity has been happening on their Slack as well recently, and I'm really a fan of the project itself. So this is what you have all together. So with these different components, you kind of achieve high data integrity and an ELT pipeline with a lot of reusable stuff, which is just working in a parameterized fashion. So now, before this, I mean, you would still think, okay, I still have to build all of this glue. But I recently found this project Meltano by GitLab, which is already on the mission of doing that and making it easy for us. And it's open source. And you can have a self-hosted version of this to achieve this kind of framework. So if you look at, so these are a few steps we would have to do, and I tested them myself to answer the question about Apache repo, you just install the package and you create and instantiate your project with some folders and files, and then you just add your extractor. So extractor is, I want data coming from tab GitHub. I want to load it into Postgres. I need to use dbt for transforming, and I will add a project or a package, they call it, as tab GitHub, which has all the SQL. And I will test it locally and orchestrate it with Airflow. Super easy. In the background, it generates a DAG um, programmatically, dynamically, and then schedules it. So let's quickly look at the code it generates to manage all this. And what it does is it writes this YAML. The point is, I don't want you to again squint and look at the YAML, but the point is, it is a templated approach. You can change a few properties of this, and you have a brand new pipeline ready for you again without doing much work. And hence, you can move really quickly, and you have achieved that meta data engineering kind of framework, which generates things for you on the fly. Different sections of this. So this is the extractor. It has some of the configurations of how you would access GitHub, the package itself, and then discover and properties. All these are different things related to Singer. I don't think I need to go into details of that just yet or in this talk, but feel free to check it out. Next is the loaders. Very simply, it's just target Postgres, give your config to Postgres so that it can access it. You're done. That's it. Then it's transform. It's the package which has all your SQL that will assume the raw data coming from GitHub API and then just do the transform to generate your business metrics or your resulting data sets. That's it. And in the end, you have your schedule, which is all the different config you want to send to your Airflow DAG, sprinkled with some other stuff in there. There you have it. At that point, I mean, you really just sit back and relax because you don't have that much work left. So that's at a high level the proposed solution. And I think it is an exciting future in this space, at least once all of this kind of comes together and matures at the point where almost Airflow is at right now in the overarching space. It is not there yet. There are some things that still need to be ironed out, thought about. One of them is the visualization of the BI layer. So I have found that there's almost a thin transformation that happens even after your resulting data sets to generate answers to the business questions, which happen in the BI layer because it's being self-served by the business users. And it is possible, even in this proposed solution, where you change the transformed data set, your resulting production data set, and everything works well, but the BI layer still breaks. And that is because the gap between the BI layer and your transform table lives in the BI layer and is not versioned in code sometimes. And it's super hard to establish all the dependencies and all that sort of stuff. So that problem still exists. The second one is analytics code coverage. So analysts are recently being brought into the habit of software best practices, SDLC practices, where they have to understand how the software goes from development all the way to production and maintenance, all this sort of stuff. And testing is a fundamental part of it. But I feel because there's so much to learn for them, they are reluctant to add and understand the importance of tests. And even if the tool promotes that, you might still find that the coverage is not strong enough to deliver the value you want. Lastly, Singer community. So Singer was started by Stitch, which is one of the prominent players in the data integration space, at least in the US. And they open sourced it, but they haven't put a lot of love in curating the community. So it feels like a bit of patchwork. And I found that sometimes tab PRs takes a long time to get merged and stuff like that. But I can see a future where single community is not controlled by Stitch, or Stitch is not the bottleneck for this to actually flourish. So definitely call to action for all of you who are interested in something like this is to please contribute, build your tabs, and make something like Meltano more mature. I think Due, who is the lead contributor from GitLab side on Meltano, is on the call as well. And he's very excited and hungry for feedback. It's been a pleasure to work with him. And in the end, key takeaways are standardized tooling for these type of pipelines will help solve a lot of problems, especially self-serving data analytics and scaling them easily. ELT works much better than ETL, and stitching together these components of grid expectations, single DBT, orchestrated by Airflow is a great solution to achieve this. It's not there yet, but I'm pretty confident we will very quickly get to a point where it's ready for production and widely adopted. Thank you.
Am I on? Yes. Thank you, Nehil.
Yeah.
It was a great talk. Thank you for the insights and how you use the technologies together. I think it's very nice stack that you have over there, especially with Meltano tying everything together.
Mm-hmm. Yeah.
If you have any questions, please go to the Slack in the Airflow Summit attendees. You can post any questions if you have. I have one first question. Did you you use two tools, for example, Great Expectations, but also DBT.
Mm-hmm.
I know they're both focused. They have support for data testing with SQL. Is there anything that you would, for example, miss in DBT and therefore you require Great Expectations, or why did you go for
Yeah,
two
that's a good question.
tools?
Good question. So DBT only works in the data warehouse. That's the first limitation, right? And so in this case, we were actually testing the source, which is GitHub API. It can be SFTP or whatever you're getting your data from. And DBT doesn't work with it. Grid Expectations, on the other hand, is just a Python package which gives you the ability to test data with all their primitives, and you can add any data source for it. So you can really just work with SFTP or API or whatever you have. So that's why Grid Expectations in the beginning fits very well, whereas DBT might not be able to operate there. And also, this is a common thing everyone is asking nowadays, where they're confused of whether they should use DBT tests or they should use Grid Expectations. They both have a good use case. I think in some ways, DBT works well with just the transform step, and they do it very well. Grid Expectations can do it, but I think if you're using DBT, then it makes sense to use all your tests and keep all of them in DBT. Grid Expectations lets you do more statistical and things that SQL is not good at. So you can use Grid Expectations wherever you want for those type of things, apart from the data sources.
Cool, thanks. I have one more question. It's really specific. I will say it out loud. Thanks. I have a question about Great Expectations. Did you have any problems integrating it with Airflow? We faced an issue with a marshmallow dependency incompatibility. Did you solve this?
Recently, I did a Dockerized version of this pipeline where you have Grid Expectations and then EL and then DBT. It is in GE underscore tutorial. I can share that after. It's an open source repo that Grid Expectations maintains. So I didn't find this problem to exist there. And probably that would be a great place to start anyway, because it uses Docker Compose and Docker to kind of bring all the pieces together. So you don't have to worry about setting all the things up locally.
Yeah. So maybe you can tell a bit more about your deployment. Like you mentioned Docker. Do you use like a Docker Compose on a VM or maybe even Kubernetes?
Yeah, so that's a good question. So I would propose that we use Docker Compose or Kubernetes for local, but definitely Kubernetes for production. Yeah. And containerize everything so it becomes super easy, and all the benefits of containerization are there for you to use. And yeah. So locally, probably Docker Compose, maybe Kubernetes, and then production definitely Kubernetes.
So one more question. What's the data warehouse that you're using with DBT? I guess it only has Redshift and Snowflake bindings as of now.
No. So actually, again, it's open source, so people can write their own bindings, and it works with Spark. It works with Athena. Recently, someone wrote a plugin for that as well. It definitely works with Snowflake. It works with Snowflake, Redshift, and it also works with Microsoft SQL Server.
Yeah, I think also
BigQuery and Postgres as well. Yes.
Yeah. Nice.
Yeah. yeah. So that's another. Yeah. All the packages I used were open source, so they're all almost extensible for specific use cases.
Yeah. Yeah, also at GoDaddy Drift, we did a lot of work on DBT, for example, making it had a support with Spark. So Spark is not like a first-class citizen, but there's like
Yeah,
a
yeah,
public binding, and it works
hmm
quite well. But sometimes you have to do some patching yourself and create a
yeah,
pull
yeah,
request, of course.
yeah,
So in my professional life, I built a lot of pipelines, and they work quite well until you have like something like schema evolution. Did you try this also with some schema change? Did you also try this with this pipeline? And do you think it would be easy to resolve, or do you have any
yeah.
ideas on
So
that?
it would be fairly easy to resolve. So what you would do is you would take you would of course have to adapt the tap to work with the new schema that is coming in, right? And then it depends on how you want to absorb the change, and if you want to go all the way through to the end, then there is some value in the change to be reflected to the user. If not, then there is a point where in DBT, what we do is we take the raw data and then we put it behind a view. So think of it like a protective layer, which is just select star on that table. So if there are schema evolution happening at the base layer, you just modify that view to still make the data look the same to downstream users, and so you don't have to change anything except the extraction part to take new schema into account.
Cool.
And it works pretty well,
Yeah, that's
and it
very nice.
reduces a lot of work.
Yeah,
But then sometimes you have to take the new schema and push it all the way through to the user, and then you have to do a little bit more work.
cool. I think that were all the questions. So up next is Bas Harenslak. He will talk about Airflow testing. So if you're writing your decks and you also want to do some testing, like he also explained, to get some code coverage, please join us at it is 7 o'clock Amsterdam time. So I guess like 5 UTC, but it's in 15 minutes. So thank you all, and see you in a bit. Let's thank Nehil. Normally I would give like an applause, but it's very difficult with the remote session. Cool.
Thank you.
Thanks all. Pretty off.
Yeah. Okay.
So
Yeah.
sorry. Oh yes. So we're back on. We have one more question. Do you use the Kubernetes pod operator to execute Singer and DBT jobs?
Yeah, so good question. Meltano is right now working on that stuff. So Meltano is writing it in a way where it's agnostic of how it's being run, and they have Dockerized everything, so you can actually just run it using Kubernetes pod operator. But I have tried all of this to work with Meltano, and there you don't need to worry about which operator do you specifically use, but they are writing config and plugins for just work with Kubernetes pod operator, which makes it super easy because they both are CLI commands in a way, right? You can run
Yeah,
dbt as a bash command and Singer tap, as I showed, as a bash command as
yeah, makes sense. Yeah, I also think it's like if you use Kubernetes, you have like this beautiful separation, right? You have
well. Yeah,
what talked about earlier with the marshmallow dependency. There's no interference between
yeah.
your orchestration of Airflow and your business logic. That's all in DBT. So that would be
hmm
a very nice
And that is the
solution.
future. I think that's how all the pipelines will move forward.
Yeah.